Hello everyone. In this video I will try to talk a bit about the flawed argument of Aristarchus when it comes to the size of the Sun relative to Earth and the distance of the Sun from the Earth. I used as a reference and to gather the necessary information the following Wikipedia article, which is on the sizes and distances. Aristarchus, as it is described here, was a Greek astronomer, and his work calculates the sizes of the Sun and the Moon, and as well as the distances from the Earth in terms of Earth's radius. Okay, and you can do the same thing that I did, read a bit on this, about this, and try to understand for yourself what his argument implies. So I will try to explain a bit this diagram because it is the most relevant information. Here we have the Sun, Moon and the Earth. So Aristarchus assumed, or maybe he had proof for it, that the celestial bodies are spherical, this including the Moon, and therefore when a half moon occurs, then it is obvious that the hemisphere of the Moon, which is closest to the Sun, will be illuminated. Okay, so about his observations we can enumerate two. The first one is whenever an observer has half a moon exactly above his position, then it means that the Sun, Moon and the Earth form a 90-degree angle, perfect 90-degree angle, because of the previously described reason. The reason is that the celestial bodies are spherical. So okay, this was his first observation, and the second observation is a measurement that he did to measure another angle, the angle denoted by this symbol phi, which sits inside the Earth circle. The angle between the Moon, Earth and Sun, he measured it to be close to 90 degrees, to be more exact 87 degrees. So this was a measurement which probably can be repeated by someone else. After this he used basic trigonometry to deduce the distance between the Sun and the Earth to be huge. So this is the resume about the information here. Now I'll go to my document. So the first question which someone should ask himself is, how did Aristarchus, which lived during this period of time, how did he know that the Earth has a spherical shape and the Earth and the other celestial bodies have a spherical shape, in order to help his argument, which concludes that the Sun is bigger than the Earth and farther away from it when compared to the Moon? That is because Eratosthenes, which came a bit later, he lived during this period of time, based himself entirely on the argument that the Sun is bigger than the Earth in order to determine that the Earth has a spherical shape. So Aristarchus assumed that the celestial bodies are spherical in order to determine that the Sun is bigger than the Earth and very far away from it, while Eratosthenes assumed that the Sun is bigger than the Earth and very far away from it in order to determine that the Earth has a spherical shape. So what can be deducted from this is that there is no secure foundation, no solid foundation for any of these arguments, because it is a case of circular reasoning. Eratosthenes bases himself on the result which should be Aristarchus's, and vice versa. So coming back to Aristarchus' argument, we can see that the trick which he used, a trick which can be observed with a bit of difficulty in his argument, is the fact that he forces the angle described by the sun, moon and earth. So this is the sun, the red one, the moon is between the earth and the sun, and the earth is at the bottom here in the diagram. So the angle described by the sun, moon and earth, he forces it to be 90 degrees because of the previously mentioned reasons. He considered every celestial body to be to have a spherical shape, and therefore an observer could see a half a moon above his position only if this angle is 90 degrees. Okay. So this doesn't mean that his premise has any proof whatsoever to support it. The only case when this assumption, this premise would be true, is if the heliocentric model would be true. So in the case of his argument, which tries to prove that the heliocentric model is true, he is using as a premise the veracity of the heliocentric model, a process which can be qualified again as a case of circular reasoning. That assumption, coupled with the observed angle described by moon, earth, sun, okay, the angle denoted by phi in the Wikipedia diagram, which he claimed to be very close to 90 degrees because he measured it and exactly 87 degrees. This forces the angle which remains, described by moon, sun, earth, to be very close to 0 degrees, an actual 3 degrees. So this, due to basic trigonometry, inevitably leads to the conclusion that there is a huge distance between the sun and the moon, and this also means that the distance between the earth and the sun is also huge. The observation of Aristarchus is that the angle described by the moon, earth, sun during a half moon is very close to 90 degrees, as I mentioned, 87 degrees. And it can be repeated in order to validate his claim. As a consequence, his argument supports the heliocentric ball-earth model, but apparently other alternative cases as well, which I will describe in the following section. So the other two cases which seem to not contradict his two premises are the following: the geocentric ball Earth, which means ball sun and moon, but which are smaller than the Earth, and the geocentric disk Earth. In this case I consider disk sun and disk moon. So let us investigate these two with a lot of care and analyze if the two premises still stand. So in the first case, in the case of the geocentric ball Earth, we have here the red circle is the sun, the white small circle is the moon, the blue ellipse is the observer, and the large white circle is the Earth. Okay, we know that if the sun is smaller than the Earth, then it has a limited range for his illumination. So this range is denoted by the yellow circle. Okay, if the sun is a ball, it illuminates equally in all directions, up to a point. So let's consider that it illuminates just enough so that it cuts the moon as I represented on the diagram. It cuts the moon with its light just like that. So it will produce half a moon above the observer if everything is aligned like this. And also you can see that the angle between the moon, observer and sun, it is 90 degrees, or as Aristarchus measured, very close to 90 degrees. Let's consider it 87 degrees, but I used a right angle here. So we can see that the geocentric model supports his premises just as well. The distance between the sun and the earth, which is denoted by this dotted line, is the same as the distance between the moon and the earth. And the sizes of the sun and the moon are the same. Okay, so it's okay for the geocentric ball earth, in my opinion. For the geocentric disk earth now, I have represented the same, almost the same diagram. We have now a disk sun and moon, which are represented by the red line and the black line, the earth, which is a disk, and the observer, which is represented by the same blue ellipse. Again, the angle between the sun, observer and the moon can be measured to be 90 degrees or close to 90 degrees, and we can imagine that the sun throws its light, illuminates up to a particular distance, enough so that it cuts the moon right here, as I represented on the diagram, thus illuminating only half of it, only half of its disk. So in this case, the observer will see closest to him half a moon, and the sun will be at a 90-degree angle, as I mentioned earlier. And as you see, the illumination area is about to leave the position of the observer, so it can be considered close to the period of night, the current time. So if you carefully analyze this situation, in my opinion, it supports the premises of Aristarchus as well. You can observe half a moon closest to the observer, and the angle between the sun, observer and moon is close to 90 degrees. Okay, so we have two cases which are alternative to the heliocentric ball earth case, and which don't contradict the premises used by Aristarchus, which means that his argument is not proved, because there are alternative cases still standing, which are possible, can be the real case, and haven't been falsified by him in any way. Now there is a second claim of Aristarchus, which is that the earth gets between the sun and the moon when a moon eclipse occurs. Well, this claim again is nothing more than another assumption. So the conclusion of this analysis is that the argument of Aristarchus doesn't prove anything certain when it comes to the size of the sun and its distance from the earth, because there are other, as I mentioned, there are other alternative cases than the one he supported, which is the heliocentric model of the cosmos and earth. Alternative cases which can produce the same observed effects as he used for premises. Okay, so that is all. Thanks for watching.